Quantum computers, the future of computing? Imagine a world where computers can solve problems in seconds that would take today's fastest supercomputers thousands of years. This is the promise of quantum computing. But how does it work? And how will it shape the future? Stick with us as we explore the mind-blowing technology behind quantum computers, their potential to revolutionize industries, and the challenges they must overcome. The future is quantum. Introduction to quantum computing. Welcome to Tech Revolution. Today we're diving deep into the world of quantum computing, the next big leap in technology. For decades, classical computers have powered everything from smartphones to AI. But we're reaching the limits of what they can do. Enter quantum computing, a new way of processing information that could redefine computing as we know it. Understanding quantum mechanics in computing, quantum computing is based on the strange rules of quantum mechanics, a branch of physics that governs the tiny world of atoms and subatomic particles. Two key concepts make quantum computing so powerful. Superposition. Unlike classical bits 0 or 1, qubits can exist in multiple states simultaneously, exponentially increasing computing power. Entanglement. When two qubits are entangled, their states are linked, even if they are light years apart. This allows for ultra-fast information transfer. How quantum computers work instead of transistors and electrical signals. Quantum computers use qubits, which operate in quantum states. Quantum gates manipulate these qubits, allowing the system to perform complex calculations instantly. Famous quantum algorithms like Shor's algorithm for breaking encryption and Grover's algorithm for search operations showcase quantum computing's power. Major players in quantum computing, several tech giants and startups are leading the race. Google achieved quantum supremacy by performing a task in seconds that a classical supercomputer would take thousands of years to complete. IBM, developing scalable quantum processors accessible via the cloud. Microsoft, Amazon, investing heavily in quantum research and cloud-based quantum services. Startups like IonQ D-Wave, innovating in hardware and applications to accelerate adoption. Real-world applications of quantum computing, AI, machine learning, enhancing pattern recognition and optimization. Drug discovery, healthcare, simulating molecules for faster drug development. Cryptography, cybersecurity, both a challenge and a solution. Quantum computers could break traditional encryption, but also enable ultra-secure quantum encryption. Financial modeling, logistics, optimizing complex market predictions and supply chains. Challenges, limitations, hardware stability. Qubits are extremely fragile and require near-absolute zero temperatures. Error correction. Even the smallest disturbances can cause computation failures. Energy scaling. Current quantum systems demand enormous resources and need years of refinement. Security risks. Once powerful enough, quantum computers could break modern encryption, threatening data security worldwide. Future predictions, industry impact. When will quantum computing become mainstream? Experts predict we could see major breakthroughs within the next 10-20 years. How will businesses and industries adapt? Companies are already preparing for the post-quantum era. Will it replace classical computing? Not entirely. Classical computers will still be relevant for general tasks, but quantum computing will dominate high-performance applications. Final verdict: is quantum computing the future? The potential is undeniable, but significant challenges remain. If the obstacles of stability, scaling, and cost can be overcome, quantum computing will change everything from cybersecurity to healthcare and AI. Now, we want to hear from you. Do you think quantum computing will be the future of technology? Drop your thoughts in the comments below. Don't forget to like, subscribe, and turn on notifications for more tech insights from Tech Revolution.